All right, can I have your attention, please, so we get started? First of all, welcome. For those of you who don't know me, I'm Tom Keller, the mayor of Toms River. We put this program on, and you're the second wave of folks, as you know, from having to wait out in the hall for the first one. But we had this room filled the first time, and a good crowd now. The reason we felt this is important is that there's so many homes in Toms River that were impacted by this storm. I don't know whether you know this, but there are at least 10,000 homes that were impacted by the storm, either knocked off their foundations, tipped over, or flooded, or a combination of both. Not all the homes have to be raised, but we think that because a lot of homes have to be raised, we want you to know as much as possible. We are not endorsing any company. We're not subscribing to any company or recommending that to you. We're only giving you broad brush explanation from a structure, from an engineering point of view, and the house raising industry and the helical pile industry. So those are the three things that I think you'll find of some interest. We're not here to talk about the FEMA maps, which are a bone of contention with all of us. We've been to FEMA, we've made our positions clear. They said no matter what we say, we have to wait until the advisory maps come out in August. So we're not here to talk about that, and we're not here to talk about the problem I'm having with the folks on the beach that won't sign the waivers to let us let the Army Corps of Engineers build the new dunes. So what I'd like to start out right now is introducing Pat Cronin. He's a professional engineer with KSI Professional Engineers, and he's going to talk to you about all of the engineering aspects of raising your home. Where is he? Oh, here he is. Okay.
Thank you. Welcome. I'd like to thank Toms River for allowing us to come here and present today and for hosting this event. We've been inundated with questions relating to the newly applied standards, and we're trying to get information out there to help you make the proper decisions moving forward. We're going to be discussing the structural foundation design for coastal construction. I'm going to cover a lot of information. Some of it may be technical, some I'm trying to keep less technical. Hopefully we'll get through it. We're going to ask everybody to hold their questions till the end. We have three presenters today, myself, Rod Scott with the home elevation industry, and representatives from Chance Anchors. So the question and answer session will be at the end of all three presentations. The outline of our presentation, we are going to cover the determination of the advisory base flood elevation and flood zones for your specific property, get into what the elevation certificate contains, the different elevation requirements for the A and V zones, the foundation requirements for both the A and V zones, how they are different, and the recommendations for coastal A's, and we're going to discuss the foundation retrofit requirements versus new construction. The key here is the advisory base flood elevation is a coastal water surface elevation of a flood having a 1% annual chance of being equaled or exceeded in any given year. It's often referred to as the 100-year storm. It's a 1% probability of occurring in any given year. It is referenced in feet from the North American vertical datum, which is equivalent, can be considered to be the equivalent of sea level, and is based on updated engineering studies and the current data. It's a snapshot in time. It's our best, it's the government's best approach to what's going on, and the current flood map represents everything that happens right now. It does not include any provisions for climate change or rising sea levels, and does not include the results from Superstorm Sandy. The current adopted firm maps are over 20 years old. The probability of a 1% annual occurrence can easily occur more frequently. A 30-year period, which is a typical mortgage, you have a 26% probability of that storm event occurring while you own that home, 1 in 4. If it's a house that's passed down with different generations, for a 70-year period, it's a 50% probability of occurring. So you're likely to see these events. The ABFE determination, it's all on a website. That website includes what exactly is your advisory base flood elevation based on 1988 datum. It also tells you where your flood zone is, the A or V zone. And then it talks about the subject of moderate wave action. If it says NA, that means you're in a V zone, so you're subject to wave heights of 3 feet or greater. If it says yes, you are defined as a coastal A with wave heights between 1.5 and 3 feet. And if it says no, you are in a standard A zone. This is what the website looks like. You type in all your information, you click Get Details, and then below the graphic it shows you how that's applied to your property. Flood zones. The V zone is close to the water's edge. It's a area subject to wave heights 3 feet or greater. After that, you're in an A zone that shows you that it's a transition area in a coastal A from a wave height of 1.5 to 3 feet, and then down to a wave height of less than 1.5 feet. So that will determine your flood zone and how it impacts your structure. The next steps in rebuilding. Most of you are here because your property was damaged and you don't really know what to do next. So the steps are as follows. First, you want to determine your ABFE and your advisory zone criteria. That was on the website that I provided. Then you need to obtain an elevation certificate from a licensed land surveyor. That tells you what your elevation is currently. You may be in a situation that your property was damaged by the storm, and you're still at an elevation that's higher than the required ABFEs. So you need to know where you are. The datum elevations are from sea level. They're not from the street. They're not from the grade around your house. So you need to know what your finished floor is currently. Then you need to determine the township's requirements for freeboard and the adoption of the ABFEs. Toms River has adopted the advisory base flood elevations, and that's what we're designed to currently before the final firm maps come out. So then you determine the township's specific requirements for rebuilding, including any approvals required, any height restrictions required, and what datum that is referenced to, and then also the building permit process, which can include architectural and structural drawings. The elevation certificate. These are the key items in the elevation certificate that we need as design professionals. The first thing we need is the top of the bottom floor. That's typically the crawl space elevation. May reference a garage elevation if you don't have a crawl space. The next is the top of the next highest floor. That's what all the ABFE information, the base flood elevation and design flood elevations are off of. That's typically the first floor framing, first floor finished floor. You can be in a situation that your crawl space or garage is determined to be your highest floor. There's options to retrofit that, so it's out of the criteria. The next is the bottom of the lowest horizontal structural member. That's only for a V zone. The elevations of V zones are determined based on the bottom of the structure. That would be the bottom of your floor joist or the bottom of a dropped girder supporting that floor joist system. Lowest adjacent grade is the lowest grade immediately adjacent to the house, and the highest adjacent grade is the highest grade immediately adjacent to the house. We use all these to design your foundation system and let you know the criteria on if you need to elevate and how high to go and what that impacts with your foundation. This is the standard FEMA form for an elevation certificate. Many of you probably already have them and have seen them. It's a requirement when you fill out for your flood insurance policy, so you may already have it. Oftentimes we need updated elevation certificates for design. You definitely need an updated elevation certificate for your insurance company. But when we have this information, we can better assist you and guide you in the right direction of what you need to do to your home. So we're going to first cover the Zone A floor elevations. A Zone A is not subject to a wave height of greater than 1.5 feet, so the floor elevation is measured from the finished floor elevation. A lot of the towns are requiring the ABFE plus freeboard requirements. They're typically 1 to 3 feet. And then it's recommended, it's not required, but it's recommended that the bottom of floor joist be above the ABFE. That allows the water to come in during the flood event. It does not wet your floor framing. It does not wet your insulation and utilities. So it's a good practice to keep that up out of the flood elevation. All utilities should be above the ABFE where practical. Now, Advisory Zone A, your concerns are to allow the water to enter and leave your home as quickly and efficiently as possible. You equalize the hydrostatic loads to minimize unbalanced water levels and pressures on your foundation walls. And then you need to address the removal of flood waters with a free draining system or by mechanical means. Mechanical means pumping, sump pumps, everything like that. The issue with that is we were without power for a number of days, weeks after the storm, so you weren't able to drain your crawl spaces. You want to protect and elevate your utilities and use flood damage resistant materials so that if it does get wet, it doesn't have any damage. The foundation criteria for Zone A, shallow spread footings are more common in Zone A. So you can be in an A zone and still be subject to erosion and scour, and your footing could still be compromised, but shallow spread footings are common in A zones. You're allowed a perimeter foundation wall that could be concrete block, cinder block, or cast-in-place concrete. You're required adequate flood venting to allow the water to come in and to get back out of the house. And crawl space construction is permitted, but basements are not. In a Zone A crawl space construction, the National Flood Insurance Program requires that the interior grade be at or above your lowest adjacent grade, so the inside of your crawl space is above the exterior grade. FEMA allows for a 2-foot maximum depth of crawl space from the lowest adjacent grade, and that requires your community to adopt specific requirements. Toms River does allow for a 2-foot deep crawl space, but they do follow the specific requirements by FEMA. Some of those I'll get into in the next few slides. A crawl space slab can be raised and sloped to the flood vents along the lowest adjacent grade. This allows you to have a free draining crawl space. A lot of the cost associated with the flood event includes cleanup and debris removal. If you allow for your crawl space to be free draining, you will still have to deal with sediment and debris within your crawl space, but don't have to deal with the water. It gets back out once the flood event leaves. There are some examples of crawl space construction. The slide on the left shows a crawl space below the exterior adjacent grade. The picture on the right shows it above. You can see that there's a vent down low, that would be a flood vent, and then there's another vent up high that is a ventilation for air. Some people say that they have vents in their crawl space, but they're not designed or detailed as flood vents. So flood vents, they automatically equalize pressure levels between the inside and outside of the structure. Let the water in, let it back out. Skip this slide, apologize. Zone A crawl space, this is the national the FEMA requirements for if you're allowed a 2-foot depth of interior crawl space below the lowest adjacent grade. This limits your crawl space height to 4 feet and has other requirements related to the flood vents. Flood vents automatically equalize water levels between the inside and outside of the structure. The bottom of the flood vent must be within 1 feet of the exterior adjacent grade. If you have a sloping site, your flood vents will be at different elevations around the perimeter. The flood vents should be distributed around the perimeter and with a minimum of 2 openings on different sides of each enclosed area. A lot of these houses have several additions that have different isolated crawl space areas. Every area needs to be vented adequately. So for Zone A, your house was damaged, you need a structural retrofit. Number 1 is you may need to elevate your existing structure. That's determined by your elevation certificate and the ABFE Determination. You want to elevate the mechanical equipment and utilities where practical. Build on top of the existing, you may be able to build on top of the existing foundation walls if they are structurally adequate. You can elevate in a Zone A, add a couple courses of block, and put your house back down. It may require strengthening of the existing foundation walls, and then you need to make sure that you have adequate flood venting to equalize the water pressure. Some areas you will need to infill your basement or your crawl space up to a lowest adjacent grade or that 2-foot max, and then develop a positive attachment from the structure to the footing itself. Oftentimes these homes are built on unreinforced concrete block foundations. There's no tie to hold the structure down to the foundation, so we need to retrofit that. Here's a quick example of a house that's being elevated. You can see the steel beams that are elevating the house, building on top of the existing wall, and setting it back down. If you're building on top of an existing foundation, you will need to make sure that the foundation is adequate for the additional weight of the block and the additional lateral forces because you're out of the ground higher. It will require foundation certification and most likely a geotechnical investigation to make sure that the spread footing is adequate. Advisory Zone V details. The V zone is subject to wave action, and because of that, it has more stringent requirements for foundation designs, and we account for more higher forces, and we account for wave action on a V zone foundation. The elevation for a foundation is measured from the bottom of the lowest horizontal structural member of the first elevated floor. Again, typically that's your floor joist or drop girders. An open foundation system is required. The open foundation system is a foundation system with piers or columns and breakaway walls, no enclosures, no solid walls. Deep foundation systems are often required due to areas subject to erosion and scour. Enclosures underneath are only allowed with breakaway panels. There are some allowances for areas with to be fully enclosed for entry. If you need an elevator or you need a protected stair, there are some allowances for that as well. Zone V floor elevation. For a Zone V, it's the ABFE plus freeboard requirements to the lowest horizontal structural member. So you may end up that your finished floor is a few feet higher than the advisory base flood elevation. Structural members are not allowed below the flood elevation except for the foundation system itself. Grade beams, piers, columns. You're allowed some limited bracing, cross bracing, knee bracing, but it's site specific and needs an engineering study. Freeboard requirements are also based on orientation of the framing members and the direction of the wave action. It all depends on which way the wave is going to approach the site and which way your framing is oriented. Ductwork, mechanical equipment, and utilities must be above the ABFE. This is a chart showing the coastal A requirements. The one on the left is an A zone subject to wave action, 1.5 to 3 feet. And the picture on the right is for a V zone showing the freeboard requirements from the base flood elevation to the bottom of the lowest horizontal structural member. Both have open foundation systems. The foundation criteria for a V zone. An open foundation system is required. There's a FEMA technical bulletin called free of obstruction criteria. This is where it tells you what you are physically allowed to have within the flood zone for your site-specific project. Deep foundation systems are often required. If your site is subject to erosion and scour, one way to address that is to use timber piles, steel piles, concrete caissons, helical auger piles, which we'll learn about later on, and other proprietary foundation systems. If you have a spread footing and the depth to the top of the footing is below the erosion and scour line, it is allowed in a V zone. It requires a site-specific engineering study, and I'll get into that in a little bit. Erosion and scour, I've mentioned it multiple times. If you don't know, erosion is the global lowering of the soil elevation. Scour is a localized lowering of soil elevation due to obstructions. So you can see you have erosion, you have isolated scour at the piles, and erosion and scour happening simultaneously. The design of the foundation system needs to account for this in a V zone. Foundation types. For a V zone, a slab on fill is not permitted. Perimeter wall, solid wall, and a crawl space is not permitted. So the two items to the right show an open foundation system. You can see the one with the footing well below the erosion and scour line, and the other one is a pile-supported foundation system. For Zone V, there's challenges trying to introduce a spread footing below the erosion and scour line. Oftentimes there's poor soil that can be soft and compressible due to the nature of the area, and there's sometimes organic fill. If there's a lagoon that was dredged and the dredged spoils were placed on your site, that cannot support a spread footing. Oftentimes the depth of the spread footing required is below the water table. So as you do the engineering study, if you have to be 4 feet down and the water table is at 2 feet, it's very difficult and costly to place a spread footing down that deep. If erosion and scour is underestimated, a spread footing can be compromised during the storm. And oftentimes existing footings are at too small or at too shallow of an embedment depth to be retrofitted for a V zone. A timber pile foundation system, the pile must have the sufficient embedment depth to account for erosion and scour. We have to design the pile, including all connections, for all loads occurring simultaneously. That's wind, gravity, flood, and wave loads, hydrostatic and hydrodynamic loads. The piles can extend above the grade, and can extend above grade and basically be a house on stilts to be your open foundation system. Or you can also cap them at grade and do a concrete grade beam with a pier system. They're an economical deep foundation system for new construction. However, if you are elevating a home, there's no means to drive a pile underneath that structure. Piles are typically 35 feet long when they start, 35 to 40 feet, and you can't stand it up and install it underneath your house. A Zone V helical auger pile, again, the pile has to be sufficient embedment to account for erosion and scour. Again, designed for all loads occurring simultaneously, including lateral loads. And helical piles will require special detailing to address the unbraced height limitations. If there is erosion and scour and the helical pile is unbraced, there are specific design methods we need to utilize to make sure that pile is stable. They are very feasible for existing structures when you're elevating and building a deep foundation system underneath an existing house, and they're also good for projects with limited site access where you can't install piles, either site access for pile driving equipment or concerns for vibration and noise for your neighbors. A V-zone structural retrofit. So if you have an existing structure that's a pile foundation system, it's possible to retrofit it for a house elevation. If you have an existing concrete grade beam and pier system, you can elevate the structure and we can potentially build on top of those existing piers. If you have a pile foundation system sticking out of the ground, it's not beneficial to splice those piles. We often cut them back down, introduce a concrete grade system and piers, and sit the house out on top of that. And again, you have to fill the interior as required to match the lowest adjacent grade in the V-zone. Now, structural retrofit for a foundation with a shallow spread footing and foundation walls in a V-zone. Number one, you have to provide an open foundation system with piers. That involves removing portions of the wall, strengthening what's there, and allowing the open flow of wave action through the structure. If a deep foundation system is required, it's going to require helical auger piles, and one of the detailing practices is either specify a round shaft pile or a concrete encasement pull-down micro pile, which we'll talk about later. That can be installed on an existing foundation system with a bracket, and that then allows you to be classified as a deep foundation system. To retrofit this, it requires new perimeter girders that would span between your piers to support the house above, and again, fill the interior as required. Now, a coastal A zone is a transition area between a V and an A zone. We're often asked, what are we required to do by code? A coastal A zone, currently, with the IRC 2009, is required to be designed as an A zone that allows you to have a solid foundation system with flood vents. FEMA strongly recommends the design of structures in a coastal A to comply with the V-zone criteria. As soon as a wave height is below 3 feet, it gets into the coastal A zone, so it's at 1.5 to 3 feet. We have seen structures significantly damaged due to moderate wave action. If possible, if you have the means to do it, I would highly recommend you design a coastal A in accordance with the V-zone requirements. The coastal A zone is currently required to be designed as an A, but it does have some additional elevation requirements as far as setting the finished floor above the ABFE. If you are designing in a coastal A, you want to evaluate the existing foundation system, including a geotechnical investigation, to make sure you're not going to be subject to erosion and scour, and that the foundation will be adequate for your house during the storm. That concludes all the structural implications of foundations in a coastal coastal construction. We're going to be doing a Q&A session at the end after the other presenters.
Well, thank you, Pat. Our next presenter is Rod Scott. Rod Scott is from Louisiana. He's here representing the home raising industry, not a particular company, but he's been in this business for years, and after FEMA, I'm sure he's got more experience than he really needed. So, Rod Scott, thank you.
Thank you. I do live in Mandeville, Louisiana. It's across the Lake Pontchartrain from New Orleans. I live in a community that is about 80% elevated in the A and B zone. And last year we took our 5th major event in 9 years. Used to be 20 years apart in the Gulf. Now we had our 5th one in 9 years, and a Katrina surge to boot on our North Shore at 8.5 feet. So I've spent 20 years in the contracting industry as a contractor, excuse me, rebuilding fire and flood affected structures and historic structures. So I know exactly what stage you're in. I want to compliment all of you for being fighters. This is a coastline that has some very, very deep embedded families and feelings towards this coastline, and you all are coming back. It's tough. This is the biggest thing you've ever experienced. In the Gulf, we measure everything pre-Katrina, post-Katrina. Yours will be pre-Sandy, post-Sandy, and every day gets a little better. Beautiful sunny day out there today, and so we're with you as an elevation industry. It's a fairly new industry in this country. Really has come up to speed since the early hurricanes of the early 2000s in the Gulf. And we're over 6,000 structures now in the Gulf that have been elevated down there. Remember, our structures are kind of different than yours. They're on pilings with a gigantic slab. And we elevate the entire concrete slab and the structure. Some can weigh as much as 500-600 tons. So just for a ranch house. So we're here to help. You have a lot of good homegrown industry here, but it was limited in capacity for what the damage is and what the need is. So you have several companies coming out of other parts of the country, Pennsylvania, the Gulf, Maryland, that have additional machinery and are bringing it to bear. They've all talked to each other. They all belong to the International Association of Structural Movers, and IASM, and the feeling in the industry is, even though there's way more work than we can get done in 1 year, all of the professionals who do this are going to hold prices just as they are in the Gulf. We're not going to raise prices just because there's more demand. The guys are really happy to be here and working, so to help you out. So let's get on with the presentation. I want to thank Tomsrivertownship, the high school, for providing the great location for all of us to learn more today. And then this month, my fees have been paid for by Ducky Johnson out of West Florida, one of several of the elevation companies that are helping you guys recover and fund my efforts up here. I don't actually do the elevation. I've just worked for many of them, and I'm now in a unique opportunity to educate you all on how this works. This is your new term that you're learning a lot about, hazard mitigation. That's the definition of hazard mitigation, and that's what we're going to do, is we're going to get this coastline up and strong and able to take subsequent events. Let's look at the history of how elevation started as a hazard mitigation. Galveston, 1900, the Great Hurricane, 10,000 people lost their lives, wood structures, no Weather Channel, no Jim Cantori telling us it was coming. About 20, 30 structures survived out of hundreds. They elevated those structures, put in a giant bulkhead on the Gulf Coast side, and dredged sand up out of the Gulf and raised the entire island 5 feet. You can see these same structures when you go down to Galveston now, because they're definitely a different architecture from the ones that were rebuilt after the hurricane. This is a typical elevation in the early days. It's kind of a gobbledygook underneath it. You'll see later with our modern elevations, we make it look a lot trimmer underneath and a lot more organized. I want to make a big note right here. Everything changed in our industry in the 50s. We'll look at some of that in the evolution of our equipment. But in the old days, we would have taken railroad jacks under that house, had 5, 6 guys with big railroad jacks, and they would have gone 1, 2, 3, and everybody tries to get the same height at the same time. In Chicago, they elevated all of Michigan Avenue. The big giant city block buildings had hundreds of men underneath the building with railroad jacks, and they had guys with whistles at each corner. 1, 2, 3, they blew the whistle, and everybody tried to get the same height at the same time. They're very imprecise and pretty aggressive on a structure. It's changed now. We use much different equipment nowadays. This is the greatest of all hazard mitigation projects in this country. Many of you on the East Coast remember the great lighthouse, Hatteras, the Great Light, moving that in the keeper's house. When that lighthouse was built in the 1800s, it was 3,000 feet from the shore. When they moved it, it was 150 feet from the shore. That's the Atlantic Ocean. It's very powerful. They moved it inland. The week they set it down on the new foundation, they had knee-deep hurricane surge. So it's stuff we're living with, and we got to be ready and prepared. This is a modern elevation in the Gulf right now. This is a concrete slab house on a V-zone foundation, open foundation. So that band around it, right under the brick, that's a slab house with brick, all elevated all at once, and then a new foundation created under it, placed back down on the new foundation, stairs, whatnot. So let's talk about why we're really concerned and why we're really going to ramp up what we're doing here. Weather's changing, the sea level is rising, whether we caused it or not doesn't matter. How are we going to adapt? I don't want to be a dinosaur 200 million years from now in a museum because we couldn't adapt. We got great engineering and great construction. This is where they predicted sea level rise back in '07, maxing out at about 1/2 meter. Now the top end of it is over 1.2 meters. That's 5 feet, 5.5 feet. So we've got to be ready for sea level rise, because as the sea level rises, the storm surges get higher. So you live in a coastal environment, we got to get you built up and safe for those events coming. So the mantra is more frequent. This is Owego, New York, upstate New York after Lee, 12 hours and 14 inches of rain, 80% inundation of this village, borough kind of situation. Of 1,200 structures, 80% went underwater, a lot like a Seabright. And so they're in the process now of getting their elevations going. They probably started with their grants 5-6 months ago. Oh, and the word Owego apparently is Iroquois, the Indians that lived there before the whites burned them out and settled. It means where the river floods. Maybe we should learn some Iroquois. And more intense. This was a hybrid storm, really the first we've ever seen this kind of a weird combination of sucking the cold in on the thing. And unfortunately, those of us in the Gulf, there's that current that runs right along the East Coast all the way to Great Britain, and it's gotten warmer and warmer every year, which provides the gasoline or the fuel for these storms. So we just need to up armor and build tough. Let's talk about the materials we use. Wood cribbing, wood cribbing, wood cribbing. We use thousands and thousands of pieces. Yellow southern pine or oak, depending on the weight of the structure. Solid masonry structures, big giant monolithic buildings. We did a museum in Cedar Rapids, Iowa a 1.5 years ago, 17,000 square foot structure, 1,400 tons. We used, I think it was 50,000 pieces of cribbing, oak cribbing. So these show up at every site. We need to maneuver them all around the site to use underneath the steel. Here's our structural steel. Comes in different lengths to go under the buildings. We'll have main steel, and then we'll have cross steel, and we basically create a crossing of steel underneath your structure with some wood cribbing to crib up the floor systems, and then the structure gets manipulated upwards. We're not promoting Deere, but lots of manufacturers of these equipment. In the old days, we had to carry the wood blocks around the house. The maximum I've ever seen is one man with 4 of those 50-pound cribs, blocks on his shoulders. Some big boys that we got in our labor crews on these things, but that machine is indispensable. It also comes with a bucket, also comes with a jackhammer assembly. We do jackhammering of the bottom of the fireplaces so that we can get our steel under the fireplaces and lift fireplaces at the same time we lift the rest of the wood structure. Here comes the accessory equipment. This is one of the rams that we use. It's a 15-ton hydraulic ram. This one is a 3-foot model. There's also a smaller model. These grooves in the housing are used to adjust the ram height as close to the steel as we can get it. And then we have a large grain screw that the head can adjust right up underneath the steel, so that when we actuate the lift, all the rams are right up against the steel and up the steel goes. This is actually recycling after a lift. They actually push the ram back down, the fluid goes back into a main reservoir in the pump system, and this is how we mount those cylindrical jacks in a high-strength aluminum base. Where's my little thing? With the dog ears that actually lock into these grooves, so we can set the height of the jack right up against that steel to initiate the lift. This is one of the greatest inventions the last 15, 20 years. This is a two-part jack. It has a steel base, a round cylindrical ram in the inner part. It's a 15-ton ram also, same as our other rams. And then a square tube on the outside with a plate on the bottom. And we call it a toe jack. So a lot of these houses or cottages are very low to the ground at the beach. We can actually, instead of having to have 3 feet of clearance to put the jack in underneath, we only need this much clearance. So we can pop a concrete block out of the foundation, slip that thing right under the sill plate of the structure, and start lifting, and we'll see some applications of this toe jack. They're made in New Zealand. They're just a wonderful part of our equipment. Here's the toe jacks assembled on a big stone fireplace. The steel beams are integrated into the steel framework underneath the structure. We use a wooden block to pad. The steel on the stone would break the stone as we lift, so we have the cushioning effect of the wood. We place these toe jacks right underneath the steel with almost no clearance, and if we've got groundwater problems, which a lot of the barrier has pretty high water tables, we can just set the jacks right there and start initiating the lift. A lot of people think you can't lift bricks on the front of houses or fireplaces. We lift them all with the house. Okay, let's talk about our equipment. This is the heart and soul of a modern elevation company. This is 1950s. This was the inventor of the unified hydraulic jacking machine. In the 1950s, we started the interstate system. President Eisenhower said we're going to make highways all around our country. We moved thousands of homes out of the way of these highways, and we just didn't have enough capacity by using those one jack, one man. So we invented, the industry and these hydraulic guys in Chicago invented this unified jacking system, which we still use today, has independent ports, and you can set the jack to the right pressure for the right weight, unify it all, and one lever actuates everybody, all at the same time, smoothly and efficiently. This is our modern equipment. You'll see it all around the coast now over the next few years. Has a hose reel for the hydraulic hose, has an accessory box that comes with the rams and the plates. There's a reservoir and a ram behind this control panel that is patented. There's only 2 manufacturers of it in the world. They cost $100,000 and take 6 months to build. So we're looking at the capacities that are needed right now and ordering machines to meet the needs of the Northeast. This is a 12 jack, and so it's on a skid system, and it comes on the back of a 5th wheel trailer. Some are mounted permanently on a truck. Just depends on the house lifter and their configurations. Here come the steps. This is a project. This is what's involved in your elevation project. Decision to go now or after the grants come. Some people are going to wait. Actually, if you rebuild now with the deed restrictions on your property, you can rebuild now if you're substantially damaged, and you have up to 4 years to get the elevation project done. Those that are under 50% damaged can make the decision to go now or in the future. A lot's going to depend on your family's decisions, future insurance costs, because everything changed last fall with the insurance industry for flood insurance. You, of course, if you're substantially damaged, 50% or more, you get a letter from the community, and that actuates some funding down here, which we'll talk about in just a second. Hire a contractor or contractors. Turnkey, everything's handled by one organization, or separate trades where you're the contractor as the homeowner and you organize everybody to show up along the way. So general contractors, New Jersey contractors can do this work and sub the elevation, or there's a few of the Gulf organizations. Down the Gulf, the elevation contractors are the general contractors and then sub out all the other work. So you're going to have different companies offering different management of your project if you elect to go that way, or go manage it yourself. Professional stamp drawings. In order to get a permit, you have to have engineer look at these plans. We also want to talk about architecture. There's a lot of great historic architecture on this shoreline. We really want to make sure that These aren't just engineered solutions, but engineered with architecture. A lot of people I've heard talking is we don't want to look like the Outer Banks, but we know we got to be elevated. So there are processes going on right now with FEMA and communities to talk about how those structures should look after they're done, especially with the grants. So we're hoping that there'll be a kind of a unique New Jersey look, just as there is now with the cottages, the wood shingle look. Some of those things will be incorporated. Elevation certificate, you've got to know where your house sits and how high you got to go in order to design the plans. So that's another document that has to be in there. Then you have to have a permit. Our elevation companies that are professional will not elevate without an elevation certificate and a complimentary, I forgot to type it in there, benchmark. We got to have something, a nail in a pole, a mark on the house. We have to know what the final elevation for that structure is going to be in order to not under-elevate you. And then we have the ICC funds for those who are damaged over 50% with flood insurance. You get a $30,000 one-time grant if you haven't maxed out your flood insurance. Of the 250, if you're up to 220, you can still get your $30,000 to help towards your elevation project. Or if you get a grant, you can use that $30,000 one-time payment as your match. Federal government pays 75% of the project. Your ICC pays the other 25%. Virtually no out-of-pocket as long as your cost of your elevation is 120 grand total. And here's all the steps to an elevation project. Utility markings, we've got to know where the gas lines are, the electric lines, the phone lines. Utility disconnects, that's handled by others other than the elevation company. Professionals. Prepare and elevate. Mobilization of the company to come in, the wood cribbing shows up, the steel beams show up. You have removed your pavers. Pavers can be palletized. Remove the precious plants and shrubberies that you've taken years to cultivate, get them potted, take them off to the side of the lot, and get them out of our way. We do tend to tear up yards a little bit with those little track machines, so there's going to need to be some landscaping at the end. We build up, we elevate, then you got to build up your existing foundation or demo the existing or a combination or build a new one, depending on what those plans that you had developed say. Set the building down on the new foundation, reconnect utilities and elevate all of your mechanical systems, water heaters, air conditioners. We don't want to elevate the building and then have those below get flooded again, and insurance requires all of that to be elevated. Steps and decks. Every egress or every opening to the structure has to have a landing at least and a staircase. Some of these properties are pretty close to the property line and they're tight together, so your building departments are going to work with you to make sure that your staircases fit within the property lines and the designs. What I always say is that if you've got, in the design phase of your project, when you're getting your plans built, make sure that you and or your designer, architect or engineer have a meeting with the planning and permitting department. It's kind of a team thing. There's a lot of these to do. You don't want to get all the way through plans, come to a permit, and then there's issues with your plans. You want to work together as a team. And then landscaping at the end to finish it all off, get those shrubs back in, get your pavers back down, or rock and gravel, or grass. So let's look at how this works. We open the foundation, if it's a crawl space or a basement. If it's a split level, we can actually go in and pick that lower level up, and I'll show you that in a second. There's two types. One is on a foundation we can get underneath the house, or there's the house that's on a slab. And we'll show you that technique. We call it a slab separation in just a second. But we can do both types of structures. So here's the steel beams. The cross beams are going through the house. And because this house is a very long house, I think this house was 70 feet long, we had to put a 12-inch box beam where they have cutouts for the beams. This also allows us to have only 12 inches of working space for the steel instead of trying to stack two 12-inch beams on top of each other, which creates 24 inches, means you've got to excavate down. So, and it also keeps the beams from doing this. It makes them rigid through this box beam system. Here's the box beam. All the lateral beams are in, and then we put a stiffener on everybody. clamp it down, and it makes it a rigid finger system of beams underneath the house. Now this is a sunroom. For some reason the company couldn't get under that foundation to lift the floor to get underneath it, so they have the steel beam system under the rest of the house. They bring the steel beams out, they bolt 2x12s to all the vertical load-bearing walls, and they slip the steel under that 2x12, and that part of the house goes up with the rest of the house without having to again try and access underneath and dig out. This shows the slab separation technique. We don't really have a picture of a ranch house slab going up yet in New Jersey. None of the ones that I've shot photographs of currently being elevated are in one of those situations. I'm sure they'll be fairly soon, because we've got a lot of them. This is a garage, same kind of thing. It's a slab construction. The vertical walls get the 2x12 bolted to them. The steel beams are coming out from inside the house where the other beams are all locked together. Couple of stiffeners, and this will then lift this garage section. Here's a very low clearance using this toe jack that we talked about. This is the kind of environment we've been in since November of last year, which is about when the first elevation started. Our guys are out there 6 days a week from before the sun till after the sun, working their tails off to get these houses up. So they love to do it, and you guys have winter up here. The guys from the Gulf showed up here with hoodies on. They learned about Carhartts, they learned about gloves, insulated boots. They all kept working through the winter. They didn't leave and go back south. So this is another application with the toe jack under a very low clearance area where the steel came out. This was actually a recessed entrance to the house. So they just brought the steel across the front and then put the toe jack underneath it, and everything went up all at the same time. Underneath our floor systems, we very often have these rat slabs, as we call them. They're a very thin slab of concrete which keeps the moisture from coming back up into your floor system in your house. We don't want to punch a hole in that. You may want to keep that concrete there. Also water table issues. So basically in this house they put the wood cribbing down on the ground, put the steel underneath the house, put the toe jack right underneath the steel beam, wood cribbing up to the floor system, and actuated the jack in this intersection of the house this way. You don't need to have your whole floor exposed like this. We can just actually open up right where that drop girder is and put that jack placement right underneath there. So one piece of plywood would have to come up so that we can get underneath there. We can access underneath crawling around in the crawl space. It takes more time. But if your house is finished, we just crawl into the crawl space and do this work. Okay, here's a jack actually working. You can see the space between the steel and the wood cribbing. It's gone a full stroke, probably close to 12 inches, and there's the steel beam, here's the support, and here's the cribs within the cribbing tower that it sits on. Here's another actuation of the toe jack in the garage. We've got about 6-7 inches of separation now between the foundation and the sill plate of the house, and we're lifting on these bolted 2x12s, and this is all chained and blocked and cribbed together, and then that jack lifts that whole assembly at the same time the rest of the house is going up. It's all unified. So here's the house at elevation, very unique architecture. Had to design, every house gets its own custom design for the steel and the cribbing. Every house is unique. Looks a little messy around there, but this is right at the end of the elevation sequence. All of this stuff gets picked up, cleaned up. The next trades come in and start the foundation. This is a V-zone elevation, a lot higher. This was up actually in Rumson, right on a waterway and a natural habitat area, and so it had to go up. This foundation will not be reused. You can see because it's in the V-zone, it'll have a new foundation underneath it. This is one that's just finishing up in Oceanport, nice, smaller kind of structure with a little porch on it. These are the pockets we leave for the beams to come down when they lower the house, and they pull the beams out, they fill the CMU blocks back in. There's our flood vents that we talked about in the last presentation, and then they'll actually put a deck on here and a support for this porch. But really nice job, 35 days, start to finish. That's an A zone. That's a reused foundation with concrete blocks coming up. So let's talk about tips for hiring your contractors. Number one, you can find the elevation contractors on the internet. All of them that are professional and licensed and have websites and experience have keywords in there. Even if they're from out of state, all of them are getting contractor licenses, and they are insured, all the professionals that are in our industry. Here's the tips. Proof of New Jersey contractor license. You want to have liability insurance. Currently, all you need in this state to elevate a house is a home improvement contractor license and $500,000 in liability. We're trying to strengthen that as an industry because that's just frankly not enough. And we need to have experienced contractors doing this because you don't want mistakes made with your house. Inexperience breeds mistakes. Also, most all of our guys that are doing this professionally for many years have $1 million liability instead of the $500,000. Cargo insurance / riggers insurance. 2-story, 3-story houses have no damage upstairs. They have all the contents in them still. Liability insurance does not cover your contents. You need to have riggers or cargo. When you're up on our steel, all those contents have to be covered by some sort of insurance. They got to be covered under a rigger or cargo insurance. And in the Gulf, that's a mandatory insurance for home elevation contractors. Do they use a unified jacking machine? If they use individual jacks or little power packs, there's no unified control of those jacks. You're going to get this on your house, and it's going to be more aggressive. It can be done, but it's going to be more aggressive on your structure. You're going to have more cracking. Remember, no house was ever meant to be elevated or moved, but with these unified machines, it has created a tremendously smooth, uniform effort for elevating homes. How many years of experience if they've got a unified machine? A lot of demand for elevation companies right now. Somebody could go buy a used machine out of the Gulf, come up here and say they have a unified machine. Make sure they've got years of experience and experienced operators for those machines. There is no school for these machines. We're looking at trying to make one right here in New Jersey at this point as an industry because you need a lot more companies to grow in this state. We went from 4 contractors to 100 contractors within about 5-6 years in the Gulf. And we had a lot of learning experience with that. But we're hoping to add a elevation machine certification program up here in New Jersey. Ask for pictures, proof of completed projects. Go to their website, look at the completed projects, talk about those projects with the contractor. And ask if the contractor's ever been sued for their work. I was a contractor for 20 years. I was never sued. There are always issues, a lot of times, with any kind of contracting and a building. You have things that come up. You resolve those issues with the people you're contracting for. It's all figured out. You get paid. Everybody goes on. Lawsuits can be a messy deal, and usually, to my opinion, means that it wasn't resolved satisfactorily with the contractor and the person.
Appreciate this opportunity to talk with you folks today. Steve and I are going to give you a solution that you've heard already this morning from Pat. He gave you one of the solutions or the options for this remediation, which are the helical pile systems. So that's what we're going to talk to you more specifically about in this portion of the presentation. The pull-down micropile system is a type of helical pile that we're going to explain to you and demonstrate to you. We'll talk about what a helical pile is, where it comes from, and how it's used. It is a deep foundation. You've heard that term today. A deep foundation, by its namesake, simply means that the loads of the building, the gravity loads, the wind loads, etc., wave loads, are transferred to a deep foundation, deeper into the soil. That would be in contrast to a shallow foundation, which, again, by its namesake, is closer to the surface. So the engineer of record on your projects will determine whether a deep foundation is required, and of course then this is one of the solutions to that, and we believe ideal for these types of situations where you need to remediate your structures after they have been raised. Steve and I are both professional engineers. I come from a company called Hubbell Power Systems. Steve comes from a local company here called Danbro, and we'll talk more about those specifically as we proceed. Hubbell is a multi-billion-dollar corporation. It's located in Connecticut, in Orange, Connecticut. You may be familiar with the name, particularly if you have, like, from a residential perspective, Progress Lighting. Hubbell, that's one of the brands of Hubbell Incorporated. The branding of the helical pile systems that we're going to be talking about today is Chance. That system is for these galvanized steel foundation systems. These products are manufactured in the United States, actually in the Midwest, in Missouri, where I'm from. And so these products are available locally, in this case through Steve and his company, which is this next slide here. And actually, this next slide here.
We're located in Philadelphia, and if anyone knows where the Navy Yard is, about an hour and a half from here. That's our office to the left, and our facilities to the right, where we keep the largest helical pile supply in the Northeast, and we get from Gary's company, Chance. We do have 100 years of foundation experience in the building, and we have a professional structural engineering staff that we provide engineering to architects, other engineers, and our installers, so that they can provide you guys with cost-effective solutions and designs for your homes.
Okay, one of the aspects, and you've heard this several times today, is the quality of the work here. Engineered solutions, certainly very important. It's also important that the contractors be qualified. Certification is certainly an aspect of that. We recommend you as homeowners always ask for the foundation repair contractors, ask them for their certification, ask for their background, what is their training. It's very important that they be well qualified and trained in order to do this type of work. So it's very similar to the house raising industry as well. We'd like to show you a little bit about the origins of a helical pile in terms of where it comes from, and just to let you know, for one thing, it's not new. It has been around for many years. This gentleman here in the picture is Alexander Mitchell. He was an Englishman, and you can see the dates here on when the concept of a helical pile, which they originally referred to as a screw pile, was conceived of and designed. So that back in the 1830s, so a 19th century type of technology, which of course is still used today. Also shown on this slide is a picture of a lighthouse structure, which was founded on helical piles. So this type of application that we're talking about in this remediation is very similar to what some of the original uses of these systems were used for. Here's an example of a structure on helical piles. This is a jetty or wharf, and so you can see in this case it's not anything new or unique. So what is a screw pile? We'll show you some animations of how they install and how they work. Basically, the best way to understand, and I refer to them either as a screw pile or a helical pile, it's both the same thing, is they act much like a wood screw into a piece of wood. The only difference being is that they don't have a continuous flight. They have helix plates, is what we refer to them as, so that it screws in with these helix plates acting as the means to screw them into the ground. They are also how we bear the loads of your buildings in the soils as the deep foundation. So the idea is to screw them in so that the plates are deep enough into the ground to support the loads of your house. It's a segmented system, so it comes in sections, which is why it's a very good option for remediation underneath a raised home, so that the contractor can put these sections together and still work underneath the structure. He has room enough to do that. With this option, we're also looking at the grouted system or pull-down micropile, so we're augmenting these piles. We refer to them as basically a system that can be readily designed for any particular application. So it's a custom designed system. The pull-down micropile system incorporates the use of the helical plates, but then it also adds to it a column or section above it that is a grout-filled cased section. And this section of the pile can typically be anywhere from 6 inches in diameter up to as much as 10 inches in diameter, depending upon the loads and the requirements of the engineer. And it can also be elevated above grade, which you're going to see. It is a system where we displace the soils and follow in behind it with a flowable grout material. Grout is a type of cement that is used in the industry. It's similar to concrete. It's not exactly the same. It has very little aggregate in it, or the gravel or the rock. You can see over here on the right is an example of a grouted helical pile being installed, and this material is the grout material. Some examples of the shafts that are formed that's actually laying on the ground after it's been pulled out of the ground. And the top of the pile as it may appear at grade if it was being terminated at grade. Here's an example of a helical pile with the grouted shaft has been exposed. You can see how they've dug down around it to demonstrate what it looks like. This is an animation. It's going to demonstrate to you how these piles actually work. You know, I can explain it to you, but obviously pictures are much better than that. The helical piles typically screw in the ground not at a high rate of speed. It's typically 10 to 15 RPM. They're installed with hydraulically driven machines, which you're going to see. Relatively low impact type of installation. At the top of that, you'll see a reservoir. We call it the grout reservoir. That's what contains the grouts as they go into the ground. It's a flowable material, so it actually flows down via gravity as the pile goes in the ground. And you've seen now what they've added on to the top of the pile. This is what we call a displacement plate, or some people just call it a digger plate. It's what actually moves the soil out of the way so that it allows the grout column to form. Very often, we have a casing that also is in place there, so we can pull the grout column in with a steel or a PVC casing that keeps the soil out of the grouted form. So we're laterally displacing material away and continuously screwing the pile, as you see, down into the soil to the depths that it can range, 20, 25 feet, for example, and to the point where the helix plates are then located at a depth where they will bear the loads of your house. So a fairly straightforward method of installation.
Okay, so why would we use this system for this type of scenario that we're at? Okay, hurricane comes in, we got to lift our homes up. What does this system provide for us? The first thing that it provides is that this type of system can be installed with low headroom underneath your homes. Small equipment, okay, minimal access areas and minimal disturbance to your land. All right. Also think, not just your property, but think about your neighbors and who's around you, okay? No vibrations. They're not pounding things into the ground, okay? Minimal site disturbance. It's small equipment. It's not going to ruin a lot of stuff around you, okay, when you're in there and underneath of it. And that's a pretty important factor, and one of the things that, there isn't the vibrations that can cause damage to other structures and even your own home. This type of pile system, as Gary said, uses those digger plates. So as you screw it into the ground, there's no dirt coming out. It's not like an auger that goes down and pulls the dirt out. It just displaces it to the side so that the grout can get there. So you will have no earth to remove from your property or sand. A lot of people hear the word steel. As Gary's mentioned, these helical piles do come galvanized with thick galvanization, and also the corrosion protection comes from the grout around the pile to protect against the shore elements that are down here. You got the salts and the breezes and the water tables of the brackish and salt waters. What it also does is this type of pile does increase the capacity by putting the grout around it and taking care of the gravity loads that push it down. Some of your homes are larger than others and will have more load. They're higher up and will have different loads on it. So this pile system beefs it up so they can take these heavier loads. And then lastly, they can be installed in a foot of water. They can be installed with high water tables that doesn't cause too much of an issue. Just a couple quick things about foundation design. I try to break it down like of what we went through to design this type of pile system and what we looked at when we were tasked with taking a look at this type of situation. First is foremost the geotechnical properties. We put thousands and thousands of helical piles in Jersey, and we know the soils that are there. So we took a look at a lot of the borings and everything that's there when we started to do our designs. Structures, what are we supporting here? Okay, we're supporting one-story home, two-story, three, you know, taller ones. So we took a look at the loads and what we were looking at for that. Where are we located? Okay, we're not down in Florida with 140 mile per hour winds. Okay, we have different types of winds, different types of flooding and action. So we took a look at all that for you guys. Governing codes. You have national codes, you have state, and then you'll have local codes. All right, all those we took a look at to make sure that the pile system that we're showing you today was in compliance with all of them. And then lastly, and most importantly, it's down to your design engineers. These are the guys you need to trust in. And over the past few days, Gary and myself have given presentations to over 170 local engineers so that in a more in-depth design, so they know how to design the system if it is necessary for your type of foundation and your type of area. Pat went over a lot of this with you guys, but just briefly here, we're moving the house above the, what they call here, the BFE or the ABFE, the baseline flood elevation. And this is for V zones here. And you can tell that at the bottom of the wave trough here, this is all the flooding that would occur. And then above the wave, here's the V zone type stuff. You get this crest of wave coming underneath your home. And then we'll raise your home up, they'll put the helical piles into the ground, and it has to be above this lowest horizontal structural member, they call it. They like to use a lot of big words and acronyms, but it's just a beam. Okay, simple design approach. This is what it comes down to. It's real simple. They raise the home up. They install the helical cased pull-down pile. We then can take the pile and extend it up to the underside of your home, lower it down and attach it. Okay? And this can be done sometimes within 10 days. Okay. Helical piles, they can be designed for all FEMA zones. So I know there's a question before you guys were in here whether, you know, some jurisdictions, they can't use them or they've been banned. That's not the case. Their FEMA has recognized the helical piles as a deep foundation system for all zones when they're designed properly, as in any deep foundation system, you know, should be properly designed and stamped. These are some of the details that I gave the engineers. Okay, this is some of the stuff that we've come up with, and we've given them many details and stuff for them to use in their systems. You can tell here's the home and the connection up top. Here's the grade, okay? Down here would be the part with the helices in the ground, and here's the pull-down pile system in there. But these are the type of engineers and stuff. We've given them these details and charts and design methods so that they can come to you with a solution that's economical for you. All right, now Gary's going to take it over here and show you some examples of where we put these in across the country.
Okay, we just wanted to give you some examples, as Steve said, to show you where these and how this can be used, give you a better sense of the process. This particular house, this beach house, was close, regionally close, Venture City, New Jersey. Again, the point being to give you an example here. A few things about this picture to look at. The existing structure, at least in this portion of the structure, was founded on timber piles, as you can see. And the timber piles were deteriorating. So this was toward the ocean side or the water side that that we're standing and looking toward the underside of the building. Notice a few things about this. First of all, notice the machine, the actual device that's doing the work. It's relatively small. This is what we refer to as a mini excavator. You've seen these, I'm sure, in many places, many locations. On the front of the machine is the hydraulic torque motor. That's what actually rotates or screws the piles into the ground. Relatively small. You can see it's hydraulically powered. The unit actually runs the motor. Also notice that you're seeing cased sections that are coming up out of the water in this case. Here's one here that extends all the way up to the bottom structural members of the house. And so you can get a sense of what we're talking about. These, of course, are going to be extended up eventually once the contractor has done the installation. It's another picture from another orientation, but again, the machine being able to work within the confines of where you have under your house. Just keep in mind, raised home is going to have cribbing. As Rod showed you in that area, so you have to be able to work within that. You're going to have various heights, anywhere from as much as, or as little as 4 feet of clearance to much more than that, 12, 15 feet of height. So you have to have equipment that can be adjustable and work within those areas. So relatively small equipment. From an impact perspective for you to consider, it's not a large piece of equipment that may be more invasive or time consuming when it comes to the installation. Another example from that same project, you can see, of course, they're working in the wet here. These case sections coming up above grade to connect with the structure. The helical pile systems can be terminated at grade, and then they can go from grade up to the structure with other types of foundations, or not foundations, with piers, as Pat mentioned. So there's a number of ways of doing this, but they can also be extended up to the base of the structure as well. One more to show you. This particular example was not in a floodplain, or it's not on the coast, it's in Atlanta. At least Atlanta's not on the coast yet. But it's a good example because it's being done for exactly the same reason. This particular house had to be raised above this localized floodplain. So the methodologies of how these piles are installed would be pretty much exactly the same way as the way they'd be done here in Jersey. So there's the house. It's already been raised. So you got a good example of that. You've already seen this in Rod's presentation. Notice the cribbing that they've done. They've obviously cleaned it up in order to allow the foundation contractor to work. If you look right here in the foreground, that's a skid steer unit, a Bobcat unit. Everybody's familiar with those, know what we're talking about here. If you look in this picture, right here, that is that unit, and it's doing the work. It's doing the actual installation of the helical pile system. Hydraulic motor mounted to the front end, rather than having the blade on the front. You take it off and mount the hydraulic motor to it, and the contractor is now installing the pull-down pile. This is a grouted shaft. He's containing his grout with a casing, and then he's installing the central steel bars right down through it, which will then have the helical plates down below, take it down to the proper depth in order to achieve his deep foundation, as we've discussed. Notice that they've had to cut holes in the existing foundation, which is slab on grade, so they have to do some of that work in order to prep the location to install the piles. But fairly straightforward process, and so they're able to work again within some fairly constricted areas because of the types, the methods, and the equipment. A few more pictures of that, but showing you the same concept. And that's it, folks. We're here now for questions, and hopefully between all of us presenters, we can certainly try to best answer them.
Okay. Thanks, fellas. That was very good.